So starting with a level 7.3, we are introducing trig identities, and what we're going to be doing is proofs. So if you see at the top, I wrote that, aka we are working on math puzzles for a little while, and this is exactly what we're doing. I will give you all of these trig identities, and it's your responsibility to kind of know what each of them are and how to kind of manipulate different expressions so that we can replace them. Because the whole goal is we're going to be doing these proofs. And it's not easy at first because we're going to be doing a lot of replacement. So some of these you have seen before. I know almost all of them you've seen before, but I just wanted to make them available to you as we move along. So some of the things that we should know. Tangent of theta. We said tangent a long time ago was y over x. We also said that the y value was the sine value. So we could say that tangent is the sine over the cosine. Likewise, cotangent is the cosine over the sine. We have our reciprocal functions. So we have the cosine of 1 over sine theta. We have secant, which is 1 over cosine theta, and cotangent, which is 1 over tangent. Okay. From there on, we get, we have these even and odd ones. So if you have a negative angle for sine, that means you just have the negative sine. Same thing with cosecant. Negative angle makes a negative cosecant because sine is odd. So with cosine, remember these are our odd functions, and cosine and secant are our even functions. So if you plug a negative angle in here, you just get the same thing as the angle. Okay, the ones that I really want to get to is sine squared plus cosine squared equals 1. You may be asking, where does that come from? So I'm just going to do a little proof right up here. Pretend we have our unit circle, and we have our x value, our y value, and our radius is 1. Well, we have x squared plus y squared equals 1. That's the Pythagorean theorem. Well, we're saying x squared is the same thing as cosine. So we could say cosine squared of our angle plus the sine squared of our angle is equal to 1. This is where that first Pythagorean identity comes from. It's just saying sine squared plus cosine squared equals 1. All from just a triangle. Now, where these other two come from, well, what happens if you divide everything through by cosine? So if you divided this whole thing through by cosine squared theta. Well, sine squared over cosine squared is the same thing as tangent squared. Cosine squared divided by cosine squared is 1 equals 1 over cosine squared is secant squared. So that's where number 2 comes from. If you took sine squared theta plus cosine squared theta equals 1 and divide this whole thing through by sine squared, well, the sines cancel. You have 1 plus cosine squared over sine squared is cotangent squared equals 1 over cosecant squared, or 1 over sine squared, which is cosecant squared. So this is where the third one comes from. All of these are based off of the Pythagorean theorem, which is why we call them the Pythagorean identities. Okie doke. Basic manipulation with trig identities. All we're doing is we're trying to simplify these as much as possible. Sometimes we have an equal sign, so we're going to try and show that one side is equal to the other side. So the first off, if we're simplifying, let's first write cotangent as cosine theta over sine theta, because that's what cotangent is. And we're dividing it by 1 over sine theta. Well, if you divide by a fraction, you multiply by the reciprocal. And I apologize because sometimes I forget to write the theta. As long as your answer in the end includes that, you should be fine. So these signs cancel out. So this whole thing is just the same thing as the cosine of an angle. So that's not that bad. Okay. show that these two are equivalent. Now, at first they might not look like each other at all, but I want to use the fact that sine squared plus cosine squared equals 1. Or another way of saying that, if I subtract the sine from both sides, I get cosine squared equals 1 minus sine squared. That's just a little manipulation, just subtract the sine. Why do I do that? Well, if I multiply the top and bottom by 1 minus sine theta, I'm going to get what I want on the top, correct? So I have 1 minus sine theta times cosine theta all over 1. If I distribute this out, which means I FOIL, these are conjugate pairs, so it's just 1 minus sine squared theta. Well, we just have right over here, 1 minus sine squared is the same thing as cosine squared. So I can replace this whole thing with this. I'm going to do that in a slightly different color. I have 1 minus sine theta times cosine theta all over cosine squared theta. That's where this comes from. Now it's just a matter of simplifying. I have 1 cosine on top, 2 on the bottom, so then I'm 1 minus sine theta all over cosine theta. So we just showed that cosine over 1 plus sine is the same thing as 1 minus sine over cosine. These are the things that we're going to be doing. Trig identities. C. Let's see what we can do. I want to simplify, which means I want to have a common denominator. Okay, so this one needs a cosine, this one needs a sine. Before I do that, let's just do it in black. I have 1 plus sine theta over sine theta plus cotangent is cosine over sine minus cosine all over cosine. It's a lot of cosines. Now, I'm going to multiply this right side by cosine theta on the top and bottom. And I'm going to multiply this left one, top and bottom, by sine theta. I'm getting a common denominator. Okay, so 1 times cosine theta, plus sine theta, cosine theta, plus, because now we have a common denominator, sine times cosine over sine is just cosine theta minus sine theta, cosine theta, all over common denominator, sine theta, cosine theta. This is just adding these two together. Now, I have a cosine theta, so that will give me 2 cosine theta. I have a sine theta, cosine theta minus these, so these cancel off. And this is all over sine, cosine. Well, these cosines now cancel, and I'm just left with 2 over sine theta. And if we really wanted to, our final answer, 1 over sine theta is cosecant, so we could write this as 2 cosecant theta. So this whole fractional expression just turns into 2 cosecant theta. Last one. Let's draw a little line here, see if I have enough room. Simplify. So sine squared theta minus 1. So you might be saying, how in the world are we going to do this? Factor the top, factor the bottom. This is just algebra. So the top factors into sine theta minus 1, sine theta plus 1, all over GCF, which is tangent theta times sine theta minus 1. Well, now these cancel, which is really nice. So then I'm just left with sine theta plus 1 over tangent theta. Now you could leave your answer like this. This answer is fine. If you wanted to go further, we could write this as sine theta over sine cosine theta plus 1 over tangent theta, because we have two separate fractions. Well, this just turns into cosine theta plus cotangent theta. And that is the most simplified you can make this problem. So let's flip it over, and we will start with the second page. So with the second page, and we're starting to call these establishing an identity. What we're trying to show in each one of these problems is that the left side is the exact same thing as the right side. So what we do with identities in order to prove something, these are all technically proofs. We are manipulating the left side to make it equal to the right side. So we will always be making the left side look like the right side. We will never cross the equal sign. So I will just emphasize this as much as I can. Never cross the equal sign. Otherwise, it starts getting really hectic and we're not proving anymore what we're doing. Okay, so with A, start off with your base. If you want an approach, if you have things that don't look like sines and cosines, make them look like sines and cosines. So I have 1 over sine theta, because that's cosecant, times sine theta over cosine theta. Now if we're multiplying these, the signs will just cancel, and I'm left with 1 over cosine theta, which is just secant theta. And this is the same thing as the right-hand side. So I didn't have to move anything over. I just showed that the left is the same as the right. Okay, with B, we're going to have to use some facts that we know about negative, even and odd properties. So just so we know, if we write these sine squared of negative angle, this is the same thing as the sine of this negative angle squared. But why we don't write it like this is because some people would think, oh, we square the angle, and that's not the case. Plus cosine of our negative angle squared. Well, the odd property for sine, which says if we have a negative angle, that's just the negative sine of that angle. Same thing with cosine. Cosine is even, so that's just cosine of our angle squared. Well, now if you square negative sine, that becomes positive. Square this, you get cosine squared. And this, by definition, is equal to 1. So we used the fact that cosine is even and sine is odd to then square it, so that makes the negative angle go away, which is still equal to 1. Okay, so with C, there is a typo. As you see, I started out and then I'm like, you can't do this. There is a typo with this problem. This should be a minus sign in between the two. If there is a minus sign, then this makes this problem super nice and easy to work with. Okay, so similar to what we did above. Ignore this for now. So the sine squared of a negative angle would just be what we showed above, positive, minus the cosine squared of a negative angle is just the same thing as this. Now we have, this would be a negative sine theta. This would be minus cosine theta, because that just becomes the angle itself. Now our next step, if I'm trying to do this, I'm going to try and factor the top. These are the difference of two perfect squares, which you can factor most definitely. So that's the sine theta minus cosine theta, and then sine theta plus cosine theta. And on the bottom, I'm going to factor out a negative 1, and we have sine theta minus plus cosine theta. These now cancel, and I'm left with negative 1 times sine theta minus cosine theta. So I'm just going to switch the signs, and that gives me cosine theta minus sine theta, which is what we want at the beginning, which makes this nice and easy to do. Last one, trig identities. I want 1 plus tangent of theta, tangent of u, plus over 1 plus cotangent of u is equal to just tangent. So we don't have a really nice way of doing this just yet. So what I'm going to do is, from the front, we have something that looks similar, but not alike. So I'm going to start writing these in sines and cosines. And you might be saying, well, why is that helpful? Well, now we can get a common denominator on the top, which is cosine. So this is cosine theta plus sine theta all over cosine theta. And on the bottom, it's sine theta plus cosine theta all over sine theta. Now that's a lot. Where did the sine come and the cosine come from? Well, this is cosine over cosine. This is sine over sine. Now we have a division, so we're going to flip the bottom and multiply. So we have sine theta, and just change the order, cosine theta over cosine theta times sine theta all over sine theta cosine theta. Yes, I know that they were used to begin with. I changed the variable, so we will go back to that. So this is sine u over cosine u, which sine over cosine is just tangent, which is what we wanted to show. So this is just a brief introduction to trig identities. Hopefully this makes sense. And really the best way of doing trig identities is to practice, practice, practice. With these proofs, we're making the left side into the right side. So we're going to spend maybe a day, 2 days on this, just on trig identities. If you like it, it becomes actually pretty fun. Okay, moving on to the next section. So a few more proofs for 7.3. Hopefully you've had a couple experience trying these out, and we'll see where it goes. So E, sine theta plus 1 over cosine theta. What we want is to get a common denominator. So what we're going to do is multiply this one by sine theta. We're going to multiply this by 1 plus cosine theta, 1 plus cosine theta. When we do that, we get sine squared plus, well, this top becomes, we're going to multiply these. So 1 squared, or 1, plus 2 cosine theta plus cosine squared theta all over sine theta times 1 plus cosine theta, which was our common denominator. All right. Next up, I have a sine squared theta and a cosine squared theta, which becomes 1. So these two become 1 plus 2 cosine theta. So 1 plus 1, this becomes 2. I have 2 and 2, so I can factor out that 2 in front. I'm left with 1 plus cosine theta all over sine 1 plus cosine theta. These now cancel out, which leaves me with just 2 over sine theta, or 2 cosecant theta, which is what we wanted at the beginning. Next up, I want to show that tan v plus cotangent v divided by this whole mess is equal to 1. So I'm going to write something really weird to start, and you might be like, how do you know how to do that? So I'm going to write this as tan v over secant v cosecant v plus cotan v over secant cosecant. Now, tangent is sine over cosine times the reciprocal of this. Well, each one of these is 1 over cosine and 1 over sine. So this is just cosine sine v plus cotangent is cosine over sine, and we have times the same thing, cosine. Now the nice things happen. These cosines cancel out. Sine times sine is sine squared. These sines cancel out, so I have cosine squared. Sine squared plus cosine squared is equal to 1, which is what we wanted. Last up, I want to show that 1 minus sine theta over cosine theta is equal to cosine theta over 1 plus sine theta. So, first things first, I want to get a 1 plus sine theta on the denominator, so that means I'm going to multiply the top and bottom by 1 plus sine theta. So I just multiply the top and bottom by this whole thing. Well, this foils into, this is the difference of two squares, so that's 1 minus sine squared theta all over cosine 1 plus sine theta. If we look at our trig identities, this is close to sine squared plus cosine squared equals 1. So this is 1 minus sine squared. So this is just cosine squared theta over cosine 1 plus sine theta. And last bit, these cosines cancel, so we're just left with cosine theta over 1 plus sine theta. And again, practice makes permanent with these. So really, the more you work and know your trig identities, the easier these become. If you do not know your trig identities, then these are really difficult to manipulate through. And then the next time, we're just going to add more to this. So we really need to focus on the trig identities that we have. All right, moving on.